To wrap up our semester, we're going to talk about cosmology. So the last couple of chapters that we cover this semester, chapters 25 and 26, are about cosmology. So what's cosmology? Cosmology, separate from the idea of astronomy, cosmology is the study of the universe itself. So we have different sort of things that we're studying in astronomy. That's the stuff that we see when we look up at the universe. But cosmology is the big picture, the universe. And since ancient times, people have looked up at the sky and they've seen the sky. They've seen stars, they've seen constellations, and they've kind of wondered what's out there. For a long time, they thought of the universe as big spheres surrounding the Earth with stars painted on it or something. Then they started to think, well, no, that's not really what it is. The stars are way farther away, and the planets are somewhere out there, and they're between us and the stars. And so over time, they're trying to figure out the nature of the universe, and that's the basic idea of cosmology. And so as time passes, they start realizing that the universe is way bigger than they thought. The Earth is bigger than they thought in the ancient times. The universe is bigger than they thought. And every step of discovery is just a bigger and bigger picture until you get something that's totally mind-blowing to most people. We ended our previous set of slides with this graphic right here, where we talk about the Earth, and at one point all that people knew was their little piece of the Earth, and then as explorers moved around, they would learn about their continent and the adjacent continent. And then they realized, wait, the Earth is a big sphere, and the idea how big it is, and exploring the Earth, and then realizing the Earth was just one of many planets that are in the solar system. And that totally changed our understanding of the universe, realizing the Earth was not the center of everything, but rather the sun was the center. And all the planets went around the sun. At the time, they weren't sure about the stars, but they were out there somewhere. And they later started to realize that stars were things like the sun, and the sun is just one of them. And then the stars are different kinds and different distances, made them different brightnesses. And so they began to think of the universe in 3 dimensions as a collection of stars. Began to realize that our galaxy is a big collection of things, and for a long time they thought the galaxy was the whole universe. And then they started to realize something about the nature of the galaxy and so forth. And at one point, all that we knew was our little piece of the galaxy there. And then Charles Shapley discovered the center of the galaxy was very far away. And so they began to realize that our galaxy was much bigger. Now, at the time, they had this big debate. Is our galaxy the whole universe, or is there something beyond the galaxy? Eventually, when Hubble discovered that those other spiral things in the sky were, in fact, objects like our own galaxy, then our galaxy became, just one of a variety of things here. And then they realized that galaxies form clusters, and so the clusters tended to clump around other clusters to make superclusters. And so the Virgo supercluster, that's the local supercluster. And then eventually they realized that superclusters, there were multiple superclusters out here, and they tended to form walls around voids. And that gives us the universe as we see it. So astronomy is the study of what we see in the sky. So astronomy is an observational science. We look at it, we categorize it, we analyze it, and then astrophysics is a merger of physics and astronomy, trying to explain how all the stuff works up there. How does the nuclear fusion work inside of stars? How do stars form? The physics of how it all happens. The thermodynamics, the nuclear fusion, the chemistry, all these things. How does all that work? That's astrophysics. But it's study the stuff in the universe. Kind of an extension of astrophysics is the study of the universe itself. What is space? What is time? Space and time. And then we realize that space and time are different aspects of the same thing. In physics, we now talk about space-time, 4 dimensions. X, Y, Z, and T for time. And so you can use these 4 coordinates four dimensions to describe something in the universe. And so cosmology then goes one step further and says, what is space? Rather than the idea that it's an absolute, Einstein shows us that space is not an absolute. And so what is space exactly? What is going on here? And how does all this work? What's the nature of the universe? What's the structure of the universe? Where did it come from? Has it always been here? Did it have beginning? The study of the universe, that is cosmology. And so at a lot of four-year institutions, there's a whole course in just cosmology because there's an awful lot to cover in the universe. And so TCC used to have a cosmology course for a short while. We only had it for a couple of years, and then the state decided they didn't like funding courses that not all community colleges had. So we lost our cosmology course at that point. But it was actually a very fun class, talk about the nature of the universe. Cosmology is a science now. In the early days, it was primarily philosophy because we didn't have the ability to measure the universe. If you cannot measure it, if you cannot put some mathematics to it, if you cannot calculate something and be able to make a measurement and predict what you ought to be able to see on your measurement, then that's not really a science. That's more philosophy. And so it's only been in recent 100 years or so that cosmology has gone from mostly philosophical to actual hardcore science. Because now we have the ability to make measurements and we have the ability to calculate things and to say, oh, wait, based on our models or understanding, then we ought to see such and such if we go look for it, and then we can go look for such and such. And so that's a testable thing. If it's not testable, it's not really a science. Obviously, we can't just go create a universe in the laboratory and study it, but we can understand how the universe works, and from that we can calculate what ought to have happened that we haven't looked for yet, and then go see if it's out there. Back at when universe first started to go, cosmology first started to go from philosophy to science, Isaac Newton was investigating it. And Newton realized that gravity was going to be very important. And so this was when they started the first idea of realizing possibly what stars were. And so his idea was, well, if the universe is this collection of stars that are out here, and all these stars are out here, then what would happen is that all the gravity of these stars would be pulling on those right there and pull them this way. But all this gravity would pull on those stars, pulling them that way, and so the universe would collapse in on itself. And so the universe would be unstable. Now, the idea of the universe being unstable was philosophically abhorrent to Newton. And so he said, well, the universe has to be stable. It's not collapsing in on itself. Again, the concept of how big it is was not even possible at that time. And so his idea was the universe has got to be stable. Therefore, there has to be wherever you are in the universe, there has to be just as much on one side as the other side. And so even if you're way on the edge here, there's got to be even more stuff even further over. So his idea was the universe has to be infinitely big. It would have to be infinitely old also if it's infinitely big, because it didn't make sense to be finite in size, because they were starting to realize that light travels at a certain speed, and so you would have to have it infinitely big if infinitely old if it's infinitely big. This led Heinrich Olbers to say it can't be infinitely big and infinitely old, because if so, then whatever direction you looked off into space, there'd be eventually a star if it's infinitely big. And so the sky should look bright, because everywhere in the sky would be stars. Very far away, but there'd be stars there. And if it's infinitely big, there'd be an infinite number of them in every direction. And so the sky would be bright. Well, we don't see a sky bright, we see a sky that's dark. And so that means it's not infinitely big. Okay, but on the other hand, if it's not infinitely big and infinitely old, then it's not stable. And Newton was arguing it ought to be stable. So this became known in cosmology as Olbers' paradox. Why is the star dark? Why is the sky dark if the universe is infinitely big and infinitely old? But if it's not infinitely big and infinitely old, it's not stable. And so then why is it even here? Why is it not collapsing on itself? And so that was Olber's paradox. And so the solution of that was really where cosmology started the process of becoming science. To really understand cosmology, we have to make a couple of assumptions. One is it's homogeneous. That means wherever you go in the universe, you have roughly the same stuff. And that is hydrogen and helium and stars and so forth. And it's isotropic, meaning wherever you go in the universe, you see pretty much the same thing. There's no edge, in other words. In other words, you can't really find the edge in the universe. It's like, the analogy here would be like a forest. Wherever you go in the forest, there's trees. Okay. And you might have different concentrations of trees or different kinds of trees, but you still have trees. Whereas if you reach the edge of the forest, that's not isotropic, because that means you have trees in one direction but not in the other direction, so it looks different one way than the other way. And so the idea is if the universe is exceedingly large, then wherever you go in it, it's going to be roughly the same stuff and look roughly the same. That means the laws of physics are the same everywhere, and therefore we can actually mathematically describe this. If this is not true, the laws of physics are different in one part of the universe than another part of the universe, and therefore any kind of physical or mathematical description of it completely fails. So these are our basic assumptions for cosmology. We call them cosmological principles. The key to understanding all this is gravity. Okay, and so that'll be the next set of slides here, is talking about gravity and how that affects the nature of space and time.